GM. Hello, everyone. Well, welcome to censorship.wtf. It's yet another new episode in the series of WTF conference. But today, we're doing something experimental. It may or may not work. We are here being part of this tale of two cities. So right now, I'm standing here on the Istanbul stage. And joining me in Prague, and you will see him shortly, is my co-host, Tim Bakel, and many more dialing in from around the world. So in the next 8 hours, we'll go on a journey from, you can see on the left side, right side of the screen, or your left side. We'll start with an overview, a bird's eye view of the problem space. And then we dive into our first chapter, which is deconstructing the Ethereum L1 CR problem. And next, we will explore some alternatives in the application infrastructure space. And next, we will take a look, sample the alternatives and the approaches from the L2 perspective. And finally, we'll bring it all back together, back to reality, and how we can impact the real world by weaving the theories into practice.
Okay, perfect. So getting back to the title, so the original full title was Alternative Frontends and Decentralized Frontends, Why and How, and we just shortened it to Alternative Frontends because every talk that we had until today shows that frontends should be decentralized, so that goes without saying. So we've seen that we can deploy decentralized frontends and using iflimo until the process support properly ENS resolution, but then ENS to IPNS to IPFS. So basically, we have a way to, let's say, ensure that from a domain we are pointing to the right resource. But what's the resource exactly? So talking about frontends, we take the source code, which can be pretty big. We'll get back to this. We generate build artifacts, and then we store these artifacts on IPFS. But if we look a bit more precisely at the source code of these artifacts, which are now safely deployed on IPFS in a decentralized manner, and we look around it, we see and we find some links to here, let's say, an API. And here it's normal IPFS. And if we look, use some tools like BuiltWith or others, we see that this is pointing to an EC2 instance, which basically that does not fill the build enough. So when you're a project, you're writing your smart contracts, you deploy them on chain that can be properly decentralized, of course, and there's many talks on the L1 that just finished now. The front end itself, the build artifacts, you can put them on IPFS, but there's also an API and which is not decentralized, at least not by default and not quite often. And I would say one more thing is the client code can be responsible for doing the RPC calls and managing the RPC calls. And even Vitalik mentioned it, that the nodes themselves, the decentralization should be well thought. And that includes the way these connections are written in the clients themselves. So decentralized versus alternative. Why alternative go as well beyond decentralized? Project can be maybe forced to shut down. Front-end operators might have legal risks, and teams can lose interest as well, abandon the code base. So we see, from instance, the market going from bull market to bear market, and some projects disappear. But the smart contracts, they're still on. Basically, users, if it's a DeFi project, can still have liquidity that they can freely withdraw using the contracts. But if there's no more front end, for many users, it will be harder to do. So that's why the importance of having alternative front ends matters for everybody, and especially for the users. And the main question then is, how can we trust these alternative front ends? And how can we trust, even beyond the build artifacts, the API? Knowing that for a reason of client diversity, which will definitely help us resist censorship, we probably need not a redeployment of the original front-end repos. So the key issue, it's trust. And how easily, when we see a front-end, when we know this is an alternative front-end, how can we trust this as a user? If it's not the original project, how do we know that this front-end is safe to use? And if we look at, let's say, a simplified architecture, so we have our build artifacts, we have multiple SDKs which have been embedded in those artifacts, create an interface which connects to RPC, API, etc. So obviously, we should trust the URL or the ENS when properly decentralized. We should trust the API, and we've seen that most often it's centralized. And we should trust the RPC node. And there's another thing, and which is one big thing we're going to talk right now about, is we should also trust the front-end implementation itself. Because if you look at what's a front end, and for instance, this is an example of one single page of Uniswap and liquidity, which overall is 500 lines of JavaScript code, not counting a lot of different libraries, SDK, components, hooks, etc. So if we include all of them, we're talking thousands of lines of code to just build an interaction. So we are including Web3 React here, React itself, lots of components. And what's lost among those lines is the semantics of the transaction that we want to perform. What exactly are we going to compute to build the transaction and then submit that transaction? And if you look, you can go on hundreds of lines, and you have bits of the semantics which are spread in this code base. Some in the page of the method itself, some in some components or hooks, and put together you see tiny bits of computation, a bit of slippage here, a bit of determining whether it's native ETH or an ERC20 token, how do we then call the estimation, etc., etc. So the front-end code is very complex, and it has a lot of dependencies. And because of that, one of the main problems, if we want to have alternative front ends and if we want to gain trust in those alternative front ends, is it's hard to verify and it's hard to maintain as well. This code base evolves permanently, and each update basically should trigger a whole new audit or a new look at. And if you multiply this by the number of projects, you have hundreds of projects, thousands of projects on chain. If you want to make sure that each of the front end that you use is safe, there's a lot of work. We thought at OKcontract about one solution that involves building a common implementation for front ends. Right now, project A has its built artifact monolith, project B, 2 and 3 as well. And the bits of semantics are highlighted in color. They are here among a lot of boilerplate or generic code. What we should do instead is maybe build a unique engine which works for any kind of transactions, and having much shorter specifications and descriptions of the transactions that we want to perform, and that will simplify considerably the way that we need to, the time we need to spend basically to look at them to make sure that we can trust them. And as well, we can also have a generic layer for UI generation. And that layer will help mostly for security. So we are reducing a bit of freedom on how we can design things exactly as designers want. But since it's automated, there's less code as well to edit. So what's this? It's trust. And the second thing is minimalism. And the way to minimally describe what transaction, what interaction we want to do is to specify it properly. And for that, we will introduce really soon the open source repos of LambdaScript, which is a purely functional language that specifies a transaction, kind of a, let's say, low-level intent or high-level description of a transaction. This is, for instance, what it looks for a swap. But if you look for add liquidity, it's about twice the size. It's still very, very short. And basically, it says, OK, we're sending to the wallet that submits the transaction. Token A is fixed, but could be left as a search box. The path, the deadline, how we compute the amount out min, which is the parameter that the method requires. And this definition, basically, we can use a compiler to generate some bytecode which describes this transaction. At compile time, we can detect some errors if the transaction is not properly specified, and then have a common transaction engines which take the user inputs and build the transaction directly from clients. Because of the separation of the specification and the runtime, basically it's a much smaller amount of code for each project and each interaction. That makes it easy to verify. And the single command runtime, that will fully open source, of course, as well, can be multiple times audited and independently. For instance, now we're working with Optimism, and we'll probably try to audit on their side, and several other people will be able to audit that common runtime. And another thing in trust is that since we have this shorter description of the interactions, anyone should be able to attest that this is a correct one. And for many people, in fact, that the community cares about, like the project itself, maybe us, maybe chains, or trusted members or in the community, or the Ethereum Foundation, who knows, can create attestations that, okay, this interactions to add liquidity on that project is valid, the computation is valid. So basically, we can attest that this is correct. And these signatures should be stored on-chain, so that is completely separate from the rest of the API nodes which provide the definition. And the last step is, as I mentioned, the automated interface generation. So UI matters for the end users, and if we only have the definition that we mentioned about the semantics, and then we have a common universal runtime and a definition to UI generator as well, which is common for all projects, then we can be sure that there are less problem with the security of the build artifacts than that we can run. You all maybe remember that BadgerDAO was hacked through the front end for 120 mil. What happened about 2 years ago was that the attackers managed to inject some code in the front end to make approvals, in fact, for user tokens to their own addresses. But they were clever. In fact, people started approving tokens, and they didn't do anything. They just kept the approval and just watched the approval going. And when a whale came in and approved for 50 million, now they say, okay, it's time to collect our benefit, and they reaped every approvals that they had. So because of that, we need to really minimize the way, in fact, we have code in our front ends. And that includes, for us, no external dependencies as well. In a similar manner, KyberSwap was attacked through Google Tag Manager. And if you look at most of the project today, and this is a discussion that was mentioned a few talks ago about data collection and privacy, basically, most of the front ends right now use Google Tag Manager. And Google Tag Manager is a vector for injection attacks as well. So if we have these two engines, we have our program, so the short definition of the semantics that we directly compile to a UI automatically. And we also have the runtime that will, from the UI, build the transaction. And that works. So in the let's say, testnets that we are doing right now, these are actual screenshots of different kind of interactions that we can generate. And so this is not fully customizable, but we'll have an SDK for that, which is another thing. But for these interactions, it's still nice enough for the end users. And we believe it's a way to reduce the complexity and so to increase the trust. So if you want to take away two things, is we talked about trust and minimalism. And I think that trust minimalism is the way to properly build alternative front ends. So if we look back at the architecture, what we propose is to have this single alternative UI, which can just take the definition, the short definition of the semantics, and build a UI for that. I didn't have time today to mention how we can have decentralized API nodes as well for that. And, but that's definitely a way to do it. So we can deploy these static builds, which can provide alternative UIs, default front ends, using generated UI and universal runtime, and as well decentralize the API nodes. So this can create, let's say, a repository of interactions where we can find interactions and alternative UIs for most of the DeFi or NFT operations or the new use cases that will come for blockchain. And what we will be able to have is the community vetting that the definitions are correct and independently that the common runtime for this interaction is correct. So that's the conclusion of this. So if you want to contribute, maybe I think we could work on an EIP to specify the transaction part and really looking to have also others contributors to that. And if you're a project and want to ensure you have alternative front ends, we'll pretty soon release everything, but you can contact us to be in the, let's say, the private betas before we publicly launch. So you have the URL where OKcontract on Twitter, and we just created, in fact, a Telegram group if you want to join it, and we'll probably announce things there. Thanks. Do you have any questions?
You mentioned very proprietary vector attacks, specifically by the injection of the Google Tag Manager and so on and so forth. We were having here the Web3 privacy also the meetup before the events over here, and one of the aspects which are there referring to the DeFi projects is that quite many of them, I don't know, due to the VC's requirements or something, they are using, you know, the Google Tag Manager and all these things to identify the user adoption and so on. This is a tremendous issue, and I don't know in which extent it is being solved by the formal specification of the transaction, when actually quite often this vector is misused by replacing the to address, you know, which is then combined with the secondary attack, vector attack of having the phishing smart contract, which seems similar but behaves differently. So is this the formal specification which should be attested and so on? Is this also addressing this issue that we are interacting with a different contract, or that we might have the replaced only like the beneficiary address?
So good question. So basically, I sum it up as how can we trust that we are interacting with the right contracts? So basically, when we specify the program, so the definition of the semantics, that includes the contract. So when I mentioned that the community can be involved, like the project itself, signing that and attesting that, this is a genuine interaction, that not only includes the values computed and submitted, but also the addresses that we're interacting with. So if someone creates a fake token, that will show up in the short definition, which anybody can review, and most probably nobody that is trustable will vet for this kind of fake interactions. Yeah, another question?
Just a second part of the question was if there was the attack directing towards the beneficiary address. So not only towards the smart contract replacement, but just replacing the beneficiary.
Yeah. So okay, the beneficiary address, then it's a user input, and if you see in the definition, let me come back here. Okay. So here we see that the beneficiary is self. And what we can do is, so for now, we have an additional field, in fact, in the specification, which are some security rules that say that this to value is sensible, and that, for instance, it should be either the wallet submitting the transaction or somehow an address which is whitelisted for that user. And this is just the beginning, but there's probably a lot that we can do in this space as well.
There are some questions on the chat. Basically, asking about how does discovery work for websites in IPFS? Is there a DHT crawler? So can you talk a bit about that?
Yeah, so here in what I mentioned, so basically we'll probably want to, for the alternative front end, so there's two ways to answer. First, we'll have just one main deployment of the engine, which takes a parameter, and the parameter being the identifier of the transaction specification. So basically, there's not too many, in fact, deployment. There should be one single address and IPFS CID, and most probably a CID which has been audited. And if we have a development version, basically, that's another deployment. But the one that we should point to once we have finished properly implemented a first revision is the audited one. And there was a second part of the question, sorry.
Asking about DHT specifically.
Oh, yeah. So right now we don't do anything specific, but yeah, of course, there's room for improvement.
Cool, thanks.